Okay, so for 59, I'm also going to factor that because it's the sum of two cubes. Oops, whoa. Get my pen situation straight here. This is 4x to the third plus 3 to the third. So that factors to 4x plus 3, 16x squared minus 12x plus 9. So each factor equals 0. Subtract the 3, divide by 4. So x is negative 3/4. This one's going to be imaginary again. So I'm going to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we get to use our calculator, so I'm going to use that to help me with the arithmetic. This is negative 432 over 32. So negative 432, I wonder if that has any perfect squares as a factor. So let's see, 432. That's even because it ends in a 2. So I'm going to divide out 2. We get 216. Let's see, 216 is even again. Oh, 108 is even again. 54 is even again. So I can keep dividing out these 2's. And we got 9 and 3 here. So we have a lot of squares. Here's a square, here's a square, and here's a square. So the square root of 4 and 4 and 9, it's going to be 2 times 2 times 3. So this is going to be 12i root 3 all over 32. Okay, we can factor out a greatest common factor of 12 in the numerator. And 12 divided by 32, that reduces. I can cancel both of them by 4. So that becomes a 3, this becomes an 8. So my final answer is 3. I'm going to multiply that back in. 3 plus or minus 3i root 3 all over 8. Now, if two of the complex zeros are 3 and 9i, I'm missing an imaginary zero. They come in pairs because when you square root a negative to get that I term, you have to have a plus or a minus. So we need to use all 3 of those. Now, it doesn't say in standard form. So I can leave it in its factored form just like that. Same thing for 61. I need a negative 7i and I need a positive 5i. They come in pairs when they're imaginary. So I'm going to use all them as my factors. And again, this one does not say standard form. So I'm going to leave it multiplied out just like that. Okay. Is each expression below a factor? It's a non-calculator problem. So what I'm going to use is synthetic division to see if I get no remainder. Bring down the 1. 1 times 2 and add. 8 times 2 and add. 15 times 2. I get 0 as a remainder, so yes, that's a factor. So for B, bring down the 1, multiply and add, multiply and add, multiply. Now, this is negative 24. That's not a remainder of 0, so B is not a factor. Okay, so I'm going to go through. I have to do the other 4. So for C, I'm going to use synthetic division with 5. Well, 54 times 5 is not going to give me positive 30, so I'm not even going to bother to do that with no calculator. And C, the answer is no, it is not a factor. Let's try D. Nope, that's not going to be 0 either, so D is a no. Okay, so let's try E. Oh, we get a remainder of 0, so E is a factor. And then for F, try negative 5. And that's a remainder of 0 again, so F is a factor. My other answers got erased, so I'll put those back up. No, no, and yes. Now for 63, it does not tell me which way I have to divide, so I'm going to use synthetic division. It's faster and it's non-calculator. So bring down the 2. 2 times 5 is 10, and add. Multiply and add. So my answer has to be a polynomial because we're dividing. I started with a third power. So that means this is going to be a degree less. So my final answer is 2x squared plus x minus 3. Okay, find the zeros and sketch a graph. So this we will use our calculator for. X to the third plus 3x squared. And I'm going to do zoom standard, get a nice 10 by 10 window. And it just wants to sketch, so I'm not going to be perfect. So I can fill in my end behavior. As x goes to infinity, the graph goes to infinity. And as x goes to negative infinity, the graph goes to negative infinity. Okay, to find the zeros, it looks like they go through exactly, but I'm just going to double check because the calculator will calculate it for me. I'll find this one first because I'm to the left of it. And as I'm doing this, I notice I'm looking at my equation there, and I see that this will factor by grouping. So I'm not going to use the calculator anymore. I'm going to factor that by grouping. It might be faster than pushing all those buttons. So I can factor out. So I'm going to factor that instead. I actually think that will be faster. So I can factor out an x squared and a negative 1. So I've got x squared minus 1 times x plus 3 is 0. So each piece equals 0. I'm going to add the 1 over, and when I square root both sides, be really careful. It's plus or minus. And here x is -3. So I have these 3 answers as the zeros for A.